students, good afternoon. Today I am going to discuss Doppler effect. I think you have already come across Doppler effect in sound and light. So I'll just give a brief description of Doppler effect. So what is Doppler effect? Suppose you have a source of waves. It may be light wave or it may be sound wave. And here is an observer, some person who is receiving the waves, who is observing the waves. If they are both are stationary, then the observer, he will get or he will receive waves the original, in original, that is the with the frequency with which the source is emitting the wave. But the situation is different when there is a relative motion between the source and the observer. If the source is moving towards observer, then the frequency of wave will increase, and if it is moving away from the observer, then the frequency, no doubtly the frequency will decrease. Similarly, if the observer is moving towards the source, then also the frequency will increase, will appear to increase actually. And if he is moving away from the source, then also the frequency will appear to decrease. Or they both may approach each other, then also there is increase in frequency, and if they are receding each other, then there is decrease in frequency. So this is all about Doppler effect, the apparent change in frequency. The apparent change in frequency due to relative motion between the source and the observer. So that is all about Doppler effect you have found in sound waves, in light waves. But these are all longitudinal, these are called longitudinal Doppler effects. But there is a difference in relativity. Here you will get a transverse Doppler effect. I am giving you the note. You can see in equation number 7, nu is equal to nu dash root over 1 minus v square by c square. Yes, that is the equation which represents transverse Doppler effect. According to classical physics, this should not exist, but it can be found only in relativity. And there is another important topic related to this Doppler effect is redshift. You should know what is redshift. As I have said, when the source is moving away, there is decrease in frequency. That means increase in wavelength. If it is a light source, what happens? The wavelength will increase. That is, the wave will move towards the longer wavelength side, that is towards the red color. If it is moving away, it will appear red. If it will move towards the observer, it will appear blue. So when we observe the distant stars, galaxies, what we observe, they appear as red, and it confirms that our universe is expanding with the big